All right, let's keep on moving on. We got predicting products next. There are 5 kinds of reactions. We need to know about all 5 kinds. However, before we start, we also need to make sure that we understand a little something about something called oxidation. Oh my goodness, where's my pen at? Oxidation reduction reaction. So that's oxidation reduction reactions. Now we can shorten that term to redox reactions, okay? Read is for reduction, ox is for oxidations, okay? Now these are going to be when you have atoms within compounds which are going to change charge, okay? So if you have atoms which change charge, then you know that you have an oxidation reduction reaction or redox reaction. So let's take a look at this. Here I've got zinc. This is a zinc atom without a charge. The 0 refers to the fact that it does not have a charge. So the zinc atom is going to turn to a zinc ion. So we go from Zn0 to Zn plus 2, okay? Now, here's something I want you to understand. Anytime you have an atom by itself, unless it tells you that it's an ion, okay, if you have an atom by itself, it's going to have an oxidation number of 0, okay? So zinc has an oxidation number of 0. Copper has an oxidation number of 0. Now, when it's in a compound, it's going to have the oxidation number that we memorized from the periodic table, okay? So we know that zinc has an always charge of +2, and chlorine has an always charge of -1, all that fun stuff, okay? So now we got -1, and then copper, so this one's a +2, all that fun stuff, okay? But if the atom is by itself, it has an oxidation number of 0. So here I've got Zn0 going to Zn plus 2. So this lost electrons. So anytime something loses electrons, it's called oxidation. Okay. And anytime something gains electrons, so this one became more negative, so the charge went down, so we know we gained electrons. The gain of electrons is called reduction. Okay, now here's how I like to remember that. I like to think about Leo the lion. Okay, so here's Leo the lion. Oh, yes. Okay, there he goes. Okay, he's got a little snout. Boom, boom. He kind of looks more like a duck-billed platypus from here, but that actually didn't turn out too bad. All right. So, anyways, Leo the lion. Okay. So, the phrase is Leo says grr. Okay. Leo says grr. Now, you're probably wondering what this means. This means that the loss of electrons is oxidation, and the gain of electrons is reduction. Okay, that's what Leo says grr means. Okay, loss of electrons is oxidation, gain of electrons is reduction. Remember, if the charge goes up, okay, if the charge goes up, then that means that you are you're losing electrons. Okay, so charge goes up, you lose electrons. If the charge goes down, you're gaining electrons. So that's another thing you need to remember. It says, as a reminder, elements by themselves, so like this fellow right here and this fellow right here, always have an understood charge of 0. Now, let's take a look at our reaction types, okay? Reaction types, I've got 5 of them. First off, we've got synthesis. Synthesis is when you take a single element and a single element, and you stick them together, make a compound. Boom, easy enough, okay? Decomposition is the exact opposite of that, okay? Decomposition is where you have a compound, okay? And then they break up, okay? And now you got 2 single elements, okay? So think about who is a famous Hollywood think about the people from Twilight. Robert Pattinson, Robert Pattinson, and Kristen Stewart. So first they are separate, okay? They're 2 single people, and then they go to Twilight and they fall in love, and now they're a couple, okay? That's like a synthesis reaction, okay? And then Kristen Stewart makes out with the guy, for those the director or whatever, and then they break up, okay? And so then you've got the couple, the Twilight couple, and then they break up, and now boom, they're 2 single elements, okay? That's a decomposition reaction. Their relationship decomposed because of her bad choices, and so they decompose. Now they're 2 single elements, okay? A single replacement reaction. Okay, think about this. This is where you're at the school dance. Okay, the fall social or the whatever it is. Okay, and you've got two couples or two people and they're dancing together. Okay, so you got a boy here and a girl here. Okay, and so all right, I made it a little more interesting. Okay, so you got a boy and a girl. Okay, and they're dancing. Oh yeah, we're having a great time. Oh, look at us, we're at the dance. Okay, and then you've got another girl who comes along. Okay, and then these folks here, they're dancing to some song by whoever. Okay, Jay-Z or whatever you kids are listening to these days. Okay, and then another song comes on by Taylor Swift, and what happens? Okay, these two they're not going to dance anymore. So what they're going to do is now these two are going to dance. Okay. And so now they're going to do their thing. They're going to dance, all this fun stuff. Okay. And now, so what we had was we had a compound and a single element, and then the reaction occurs, and now you have a new compound over here and the old single element over here. Okay, so it was a switcheroo. That is a single replacement reaction. When we have a double replacement reaction, we've got two couples. Okay, you got two couples and they're all dancing. Oh yeah, look at us, we're having fun at the dance. Okay, this is awesome. We like to dance. And then a new song comes on, but oh, we're just friends, okay? We can dance with whoever we want to, okay? And so then you got, oh, no. Yeah, there you go, okay? Oh, yeah, now we're dancing. Look at us, okay? Oh, yeah. Oh, we're all dancing, okay? And so then, yeah, so that's what happens, okay? So then that's a double replacement, okay? You start off with two compounds, and then you do a little switcheroo, and now you've got two other compounds that are doing their thing, all right? So that, my friends, is a double replacement reaction. Okay. Lastly, you've got a combustion reaction. I don't have anything fun like this for combustion reactions, but nonetheless, a combustion reaction is where you have a hydrocarbon or an oxyhydrocarbon. Okay. Remember what a hydrocarbon is from last semester? That's where you have an organic compound made of carbons and hydrogens, or an oxyhydrocarbon made of carbons, hydrogens, and oxygens. You're always going to have the same situation, okay? They will always react with oxygen. They will always make carbon dioxide, and they will always make water, okay? Every single time. Hydrocarbon or oxyhydrocarbon reacts with oxygen, forms water and carbon dioxide. Boom. Okay, let's take a look at each of these following reactions and tell what they are. So this is a compound, and then this is another compound with a smaller little something or other. Okay, now this is not a switcheroo. Okay, this is not a switcheroo sort of deal. Okay, nobody switched places. What we did here was we made this smaller. Okay, we took it from KNO3, now it's KNO2. Okay, so this is going to be a decomposition reaction. Okay, now this one, KBr plus Cl, this one is a switcheroo sort of situation. Now we've got KCl plus Br2. So this one is, oh, I'm at the school dance, and now I'll switch to a different partner. Okay, so this one is single replacement. Okay, this one here, I've got a compound and a compound, and now my anions switch places. So where I had aluminum nitrate and sodium hydroxide, now I'm going to have aluminum hydroxide and sodium nitrate. So this is this situation. Two compounds, and there it is, kind of. Okay, two compounds form two new compounds. Okay, so this is double replacement. Okay, here I've got a hydrocarbon plus oxygen yields carbon dioxide and water. Boom, combustion every time. Okay, every time. This one, single element plus compound, new single element. Okay, that must be, blah, blah, blah. Okay, so that is single replacement. And lastly, I've got two smaller deals coming together to form one larger product. Anytime you only have one larger product, okay, that one's always, every single time, going to be synthesis. And that's how it's done.